Welcome back, everyone. If you are a focused learner trying to figure out how to actually master software engineering and, really stand out in today's crazy tech landscape, well, you are in exactly the right place. Today's explainer is all about the 2026 developer lifecycle. We're going to map out exactly how to build your skills, create projects that actually matter, and then use the ultimate hack for locking down your knowledge, which is teaching others. Okay, let's dive right in. Because here is the massive question we have to tackle first. How do you stand out in 2026? I mean, we're living in an era where AI tools, think GitHub Copilot, they're already writing roughly 40% of the standard boilerplate code. So if AI is doing all the heavy lifting on the basics, how are you going to rise above the noise and prove your actual value to those top-tier companies? To answer that, here's our master plan for today. We'll be covering the 2026 engineering roadmap, escaping tutorial hell, building project-based portfolios, the amazing power of teaching, creating engaging content, seeing teaching in action with binary search, and finally embracing the growth mindset. Let's jump straight into Section 1, the 2026 engineering roadmap. Look, you need a systematic, step-by-step path to getting those modern, highly paid skills. You really can't just learn random languages and hope for the best. You need a structured plan that adapts to what the industry actually demands right now. So looking at this 6 to 12-month timeline, you start off in months 1 and 2 with the absolute fundamentals. We're talking Python or JavaScript, your basic syntax, loops, and those core data structures and algorithms. Then, by months 3 and 4, you're scaling up into backend APIs and SQL databases. But, and this is critical, look at months 5 and 6. This is that massive 2026 shift. You absolutely have to move into deploying production-grade AI integrations, prompt engineering, and containerization with Docker. Then, month 7 and beyond, that's all about advanced systems design. Seriously, this is how you future-proof your career. Moving right along to Section 2, escaping tutorial hell. So once you actually have your roadmap, you've got to avoid the absolute biggest trap for new developers, and that's passive learning. It creates this totally false sense of understanding. We've all been there, right? You sit there, watch a polished tutorial, and it all makes perfect sense. But the second you open a blank code editor, nothing. Your mind goes completely blank. Project-based learning, on the other hand, is the exact opposite. Writing code, inevitably making mistakes, and struggling through that debugging process, that is literally the only way you build true muscle memory. It's exactly like the old saying, you cannot learn to swim by reading a book. Programming is a problem-solving tool, period. It's an active exercise, and you're only going to get better at it by picking it up and actually building things. Which leads us perfectly into Section 3, project-based learning portfolios. This right here is your definitive ticket out of tutorial hell. You need to build a tiered, progressively complex portfolio of real-world projects. Let's look at how you map out that progression, using examples from a great list of 200 project ideas. As a beginner, just focus on API basics. Build a simple weather dashboard using the Open Weather Map API. Once you hit that intermediate stage, start tackling real-time data by building a full-stack chat app using socket.io. And then, at the expert level, that's where you bring the whole shebang together with SaaS architecture, like building a complete project management tool integrated with Stripe for billing. This kind of project ladder is exactly what proves your skills to any employer.
All right, Section 4, the power of teaching.
Okay, so if you really want to lock down your own mastery and build up some serious industry authority while you're at it, you have to teach what you are learning out in public. When you take the time to visually map out a really advanced concept, like acquiring an image, processing it with deep learning models, and interpreting it, you're avoiding cognitive overload for your students. But even more importantly, you are permanently cementing that knowledge right into your own brain. I absolutely love this quote from a free Codecamp contributor. They started making JavaScript tutorials way before they ever got their first tech job. And it turns out, the actual process of researching topics to make those videos is what turned them into the expert that modern employers are so desperate to hire. Teaching is, hands down, the ultimate learning multiplier. Next up, Section 5, creating engaging tech content. So, how do we actually pull this off without it turning into a second full-time job? Well, the absolute secret to a flawless, unedited take is all in your pre-recording workflow. First, prep your room and your notes. Know exactly what you want to say. Second, clean up your coding environment, disabling any pop-ups or distractions. Third, always do a test recording to check your audio. And fourth, when you're recording, narrate slowly and visually explain every step you're taking. Now for some rapid-fire, high-impact tips that will literally save you hours. First, get a dedicated USB mic. That audio kills viewership instantly, for sure. Next, massively increase your code font size. Remember, like a third of your audience is watching on their phones. Throw on a high-contrast theme, like community material theme, so the logic really pops, and disable those blinking cursors. Oh, and my absolute favorite trick, use automated silence detection tools to instantly chop out the dead air when you're just thinking or typing. That tip alone can cut a 45-minute editing session down to 10 minutes. Real game changer. Let's put this into practice with Section 6, Teaching in Action. For the 11th rung of our LogicLadder Roadmap, let's dive into a binary search example. This lesson is the absolute perfect follow-up to our explainer on Big O notation because it's a super practical demonstration of moving an algorithm from linear to logarithmic time. You start with a hook. Ask your viewer, hey, if I asked you to find a specific name in a phone book with 1 million entries, would you start on page 1 and check every single name? That is linear search, or O of n time, meaning it could take 1,000,000 steps. But binary search? That's the developer's secret weapon. It's the phonebook flip. You just open it to the middle. If the name starts with Z, boom, you instantly throw away the first half of the book. Every flip eliminates 50% of the remaining work. That shifts your algorithm to O of log n time, letting you do that exact same task in just 20 steps. 20! That is the exact logic powering modern database searches and high-speed agentic AI retrieval today. Now, to break down that divide and conquer strategy without totally overwhelming your viewer, clearly define 3 pointers: low for the start of the search range, high for the end, and mid for the computer's guess. While writing out the live C++ implementation, you want to narrate everything aloud for accessibility. Say something like, we calculate our midpointer by adding low and high and dividing by 2. Use Turing shot visuals like a manual zoom right in tight on that while low is less than or equal to high loop condition to really show the engine of the search. And then use your annotation tools to literally draw a line through the discarded half of the array. It beautifully reinforces that O of log n growth curve. Doing all this brings us to a great realization. The best edit is the one you never have to make. Setting your tutorial up like that with huge fonts, clear analogies, and live visual annotations means your recording basically is the final product. You set your environment up perfectly, and you completely avoid the nightmare of scrubbing through a post-production timeline altogether. Finally, Section 7, Embracing the Growth Mindset. Look, as you learn, build, and teach, you are going to hit bugs and fail. It's inevitable. But here is a brilliant trick for both learning and teaching. Embrace those errors, whether they're intentional or not. Mistakes are live, debugging teaching opportunities. For example, when you're teaching that binary search algorithm, try running it on an unsorted list. It'll return the wrong result. Use that sorted requirement trap to explain that binary search only works if the bookshelf is perfectly organized to begin with. Leaving those syntax errors or logic traps in your recordings teaches your audience how to logically debug, and it proves that choosing the right tool is just as crucial as knowing how to use it. Which brings us to one last, pretty provocative question to wrap up this explainer. The tools have totally changed. AI can write the basic code now. So in the age of AI, are you just going to sit back, consume tutorials, and stay stuck in tutorial hell? Or are you going to step out of your comfort zone, build complex projects, teach others, and actually cement your own authority? The 2026 developer lifecycle is sitting right there waiting for you. Get out there, start building, and share what you know with the world. Thanks so much for joining me on this explainer, and I'll catch you in the next one.